Hello there. Today I'm going to present to you the results of my Machine Learning Foundation final project. For this, we had a data set where we're trying to predict the electro output based on these four different features: ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. So for the model approach, since I'm trying to predict a numeric value based on also numeric features, I decided to use a regression model. For the model building, I ended up using four different models. I know that the test required only two, but I wanted to try different models. So I used a combination of different features and also linear values for the features and also polynomial values for the features. For the model evaluation, I decided to use MAE, the mean absolute error, mainly because for this, I felt like it was best for interpretability because it would be easier for me to just determine on average by how much off would my model be of the actual value. And the model interpretation, the end result was that my model on average was off target by 3.54 megawatts. So let me show you my approach. The first thing I had to do was separate the main data set into two different buckets. I separated 20% for testing and 80% for training. And on my training data set, I also broke it down even further for the training subset and for the validation subset. So I use 75% of that for training and 25% of that for validation. And this is what I end up with my training subset. I squared each individual feature. So this is ambient pressure squared, as you can see here in Excel, and all the other features as well. Because I wanted to test not only the linear value, the actual value, but also the relationship with the polynomial or the squared version to see if there was a relationship there. And I ended up getting good results. And this, of course, is the electro output or the actual values. Then the first thing I did was running individual regressions for each feature because I wanted to see which one of them had a significant value with lower p-value and also a higher r squared. I learned that the ambient temperature and the exhaust vacuum had both had the highest r squared and a significant value statistically speaking because of a lower p-value. For ambient pressure, not so much. We can see the adjusted R square 0.26, and for the relative humidity 0.15. They're still significant, but not so much. The next thing I did was running, my first model was my benchmark, was a multiple regression using all different features. And we can see that the adjusted R square is very significant, almost 93%. And all different p-values are very low. So very good benchmark for me to start with. My second model, I decided to use all four features, but also the four squared features to see if there was a relationship there. My adjusted R square was slightly better than the benchmark I created, but one thing I noticed was that both relative humidity and the exhaust vacuum squared showed a p-value above the 0.05. So I decided to run a third model without those two features, including only these six guys. And I got a slightly better R squared, and all the p-values here were very low, so still statistically significant. And finally, my fourth model, I decided to only use two out of the four features. So I decided to use those two that had the highest R squared when running a single regression. So I decided to use temperature and vacuum. This is my fourth model, and I can see this, the adjusted R square is actually lower than the multiple regression or my benchmark. Then what I decided to use to compare the performance of these four values, I went into the validation subset and I applied the mean absolute error for them. So I created calculations here based on the results of the regression for each of my four models. And I ran that against the values. Then I compared that with the actual result, and then I got the mean of all these different readings. And these colors up here, as you can see, these are the mean absolute error for each of my four models. And then model 3 was the winner with the lowest mean absolute error. And model 4 was the worst of them, with model 1 and model 2 performing quite well as well. So I decided to choose model 3. And when I applied that to my training set, to my test set, to the 20% that I set at the very beginning, when I applied that model, I got a mean absolute error of 3.54, meaning that on average, my model is off of the actual value by 3.54 megawatts. So it's very, very close, I'd say, since we're looking at 436 as the absolute value, being like 3 off is about 1.5%. So it's not so bad. And it was very, very interesting to see the different combinations here and comparing their results. So it was very, very nice to apply all that I learned on the machine learning course using this Excel. And I plan to try other tools as well, like Google Cloud is the next one I'm going to try. But this is the presentation for my final project. Hope you enjoy it.